For almost 100 years, Pluto was the frozen little dot at the absolute edge of our solar system. It was the last stop on every classroom poster, widely written off as a lonely, lifeless rock drifting in the dark. Then, in August of 2006, the International Astronomical Union took a vote in Prague. Most of us stopped paying attention. Even when NASA's New Horizons probe finally reached it in 2015, it was a one-way trip. The spacecraft screamed past at over 30,000 miles per hour, capturing a fleeting snapshot of smooth, heart-shaped plains and towering ice mountains. The images revealed a strangely active surface, but because the probe couldn't slow down, it left researchers with a massive, unresolved mystery. For a century, our limited tools forced us to treat this distant world like a closed book. We assumed its frozen exterior was the entire story, leaving the possibility of an active interior entirely unexamined. That changed when the James Webb Space Telescope came online. Webb doesn't operate like a standard camera. Instead of just taking photographs, it captures the faintest beams of infrared light bouncing off distant objects and splits that light apart. This allows it to read the exact chemical fingerprint of a world billions of miles away, tasting the atmosphere and surface molecules from a parking spot near Earth. When researchers pointed Webb's golden mirrors toward Pluto, the incoming data revealed a system of chemical interactions and thermodynamic cycles. The telescope captured evidence of a world that is physically, constantly changing. To understand the nature of these changes, we have to travel through Pluto's anatomy layer by layer, starting at the very top of its alien sky and descending all the way down into its core. At its highest altitudes, Pluto hosts a vast, thin atmosphere. Suspended within this air are hundreds of miles of blue haze, stacked up like delicate sheets of tissue paper glowing in the faint sunlight. On planets like Earth, an atmosphere and clouds act like a blanket, trapping solar heat and warming the surface. This animated cross-section shows how Pluto's haze does the opposite. When weak sunlight hits these atmospheric particles, they absorb a tiny bit of energy, but then immediately beam it straight back out into the vacuum of space as infrared radiation. This creates a self-sustaining air conditioning loop. As the atmosphere radiates heat away, the planet's surface temperature drops. That extreme cold causes more gases to freeze out of the air, creating even more particles, which thickens the haze layer and kicks even more infrared energy out into space. It is a massive refrigeration system running on autopilot. On a world where temperatures already sit near 400 degrees below zero, the sky is actively working to freeze the surface even further. Moving down below that cooling haze, the faint ultraviolet sunlight drives a strange chemical reaction. It strikes the simple methane gas suspended high in the air and snaps those molecules apart, stripping carbon and hydrogen atoms away from each other. But those fragmented pieces don't just float away. They stick together, recombining into longer, much heavier carbon chains. These complex carbon-rich compounds are known as tholins. Because these tholins are heavy, they slowly drift downward through the thin air, settling onto the icy surface in a relentless, slow-motion red snowstorm for the last 4 billion years, piling up into vast, dark plains near the equator. These specific tholins belong to the exact same family of organic molecules that scientists believe rained down onto Earth billions of years ago. They are the same carbon-rich building blocks that provided the starting materials for life on our own planet. Pluto's chemistry doesn't stay confined to its own surface. If we pan 12,000 miles across the empty vacuum, we find Pluto's largest moon, Charon. For years, astronomers were puzzled by the dark, reddish-brown stains capping both the north and south poles of this otherwise gray, cratered moon. Webb's data finally revealed an invisible bridge between the two. Because Pluto's gravity is incredibly weak, it can't hold on to its entire atmosphere. As you can see in this diagram, methane gas literally leaks out into space, drifts across the 12,000-mile gap, and gets captured by Charon's gravitational pull, settling at its freezing poles. Once that stolen gas freezes onto the moon, intense cosmic radiation bombards it. This radiation cooks the methane, breaking it apart and rearranging it into the exact same red tholins that fall like snow on Pluto. Pluto's systems are active enough to breathe part of its atmosphere onto another world, painting its moon with organic compounds in the total silence of deep space. But the most significant evidence of activity requires us to plunge directly through Pluto's surface. Past the tholins and the nitrogen plains, we drop through roughly 100 miles of solid water ice that is frozen so solid at these extreme temperatures that it acts exactly like bedrock. Below that frozen crust, Webb and New Horizons found evidence of liquid. A massive gravity anomaly under the planet's smoothest plains suggests a dense concentration of material. On top of that, surface images show massive ice mountains with deep depressions, cryovolcanoes that push a slushy mix of liquid water, ammonia, and methane up from beneath the ground. This animation illustrates the heat source driving that liquid upward. Deep at the planet's center sits a rocky core, packed with radioactive elements. Over billions of years, these elements slowly decay, releasing a small but continuous supply of heat. That radioactive heat is just enough to melt the very bottom of the 100-mile-thick ice shell. It maintains a massive, pitch-black ocean of liquid water, sealed away from the surface and churning under unimaginable pressure. Beneath a frozen and hostile exterior, Pluto hosts a warm, liquid interior that has remained active for billions of years. When we pull back and view this planetary system, the isolated details form a single context. We have an atmosphere dropping organic chemical snow, an invisible leak painting a neighboring moon, and a hidden ocean of liquid water insulated by miles of solid ice. Under that 100-mile shell of ice, Pluto has maintained a stable environment of liquid water, a steady supply of heat from a decaying core, and a continuous rain of carbon chemicals for over 4 billion years. These conditions have existed side by side in total isolation since the solar system was young. To be clear, Webb has not found evidence of actual alien life here, but against all odds, this distant world contains the essential ingredients for it, fully assembled and waiting in the dark. And Pluto is not out there alone. It sits inside the Kuiper Belt, a ring in the outer solar system crowded with hundreds of thousands of similar icy objects. Which leaves us with one massive question. If a single dwarf planet we dismissed for decades is secretly hiding an underground ocean and raining organic snow, what are the trillions of other unmapped frozen worlds hiding from us? For a century, Pluto represented the outer limit of our knowledge. Now it serves as a map for the trillions of other worlds waiting in the dark, suggesting the most distant reaches of our solar system are far more active than we imagined.